Hey there, wonderful viewers. Today, we're diving into the fascinating world of statistics, and we'll be talking about the key concepts of exponential distribution. And it's a topic that's both important and intriguing, so let's get started. First things first, what is exponential distribution? Exponential distribution is a probability distribution that deals with time between events. It's all about understanding random time intervals, whether it's the time between bus arrivals or customer arrivals at a store. Exponential distribution helps us make sense of these time gaps. Now, let's talk about the probability density function, or PDF. This is the mathematical heart of exponential distribution. The PDF formula contains fx. This represents the probability density function, which gives the probability run of the random variable x, taking on specific value of x. While lambda is the rate parameter and it determines the average rate at which events occur in the distribution. It's the inverse of the mean or average time between events. A higher lambda indicates events occur more frequently, while lower lambda implies longer intervals between events. E is the mathematical constant approximately equal to 2.718. While x represents the time you're interested in which is the variable you want to calculate the probability for. And now that we're done on our discussion of our key concepts of exponential distribution, now let's proceed on our formulas. So, see ya!
Hello everyone, today we're going to dive into the formula for the exponential distribution. This distribution is widely used in the field of statistics and probability theory. The formula for the exponential distribution is typically pronounced as follows. F of x given lambda equals lambda times e to the power of negative lambda x for x greater than or equal to 0 and 0 otherwise. F of x given lambda refers to the function f of x given to the lambda, or the vertical bar is usually read as given. Lambda is the Greek letter, the upside down y, which represents the rate parameter in the formula. E refers to the Euler's number, which is approximately equal to 2.71828. It's a mathematical constant and the base of natural logarithms. To the power of is how exponentiation is usually pronounced. So e to the power of negative lambda x is how you'd say it. For x greater than or equal to 0 and 0 otherwise specifies the range of x for which the formula is valid. Remember, when saying the formula out loud, it's important to clearly distinguish between the different elements to avoid confusion. The probability density function of an exponential distribution is given by that formula. So the lambda is the rate parameter and also known as the inverse of the mean, and E is Euler's number. It represents the time. It is the variable that represents the time between events. This formula tells us the probability of an event happening in a given time period, assuming that the events occur independently and at a constant average rate.
Hey there, fellow seekers! Today, we're diving deep into the mathematical ocean of a probability distributions, and our compass is pointing straight at the exponential distribution. But hold on tight, because we're not just exploring, we're unlocking the secrets of its dynamic too, mean and variance. Now let's talk about the mean of the exponential distribution. The mean, or average, is a measure of a central tendency. For the exponential distribution, the mean is simply the inverse of the rate parameter, often denoted by lambda. So, if you have a higher rate, you get a smaller mean and vice versa. It's like a mathematical seesaw. Change one and other responds in kind. Next up, variance. Variance gives us an idea of how spread out our data is. For the exponential distribution, the variance is just a square of the inverse of the rate parameter. Again, it's this delicate dance between rate and spread. Higher rate, smaller spread, lower rate, and larger spread. But why does this matter? Well, understanding the mean and variance of the exponential distribution helps us make predictions and analyze data in a wide range of fields, from telecommunications to finance.
Exponential distributions applications. One of the widely used continuous distribution is the exponential distribution. It helps to determine the time elapsed between the events. It is used in a range of applications such as reliability theory, queuing theory, physics, and so on. Then some of the fields that are modeled by the exponential distributions are as follows. So first, we have the exponential distributions helps to find the distance between mutations on a DNA strand. Next is calculating the time until the radioactive particles decays. Then third, helps on finding the height of the different molecules in a gas at the stable temperature and pressure in a uniform gravitational field. Helps and last, helps to compute the monthly and annual highest values of regular rainfall and river outflow volumes.